Why do we need to use antigen retrieval? And we typically do this because formaldehyde cross-linking using those methylene bridges can mask certain epitopes. And so to start with, we always use HERE. So HERE stands for heat-induced epitope retrieval. And this is the most common epitope retrieval and is also the most gentle. And typically we use a pressure cooker or sometimes a microwave. And first you would get it to around the temperature of 90 to 95 degrees, and we would do this for around 20 minutes. But again, it does depend on the protocol you're using and the antibody and tissue you're using as well. So do be sure to check what your manufacturer recommends for your epitope retrieval step. And Tris EDTA tends to be the best buffer here. So if you don't know where to start, then first try out with Tris EDTA before moving on to citrate buffer. And Pierre, on the other hand, stands for proteolytic induced epitope retrieval. And this is good if you have a difficult epitope recovery. So say you first tried with HERE and cannot get any staining, then I would move to proteolytic. And this uses enzymes such as proteinase K, where you heat at a milder temperature of 37 degrees. However, this can damage tissues because of the enzymatic retrieval. So I would use it sparingly and be aware that you might have to have some optimization steps here too. So how does this work? So here, the exact mechanism is kind of unclear, but it is thought that the thermal energy surrounding this HERE process can break these cross-links that bind the surrounding proteins or peptides. But it's also thought that it might act by acting as a calcium chelator by removing bound calcium ions from the site of cross-links. And this is supported by the fact that, as I mentioned, some of the HERE buffers, such as citrate and EDTA, act as calcium chelators, so supporting this fact that HERE might be working by removing these bound calcium ions. And proteolytic is a lot more simple, so this simply acts as breaking peptides that mask epitopes and breaking these methylene bridges. So this is how Pierre works as epitope retrieval. So here are just some examples. So this is human tonsillitis tissue stained with a CD14 monoclonal antibody. And if we look without antigen retrieval and in a slightly higher antibody dilution, you really cannot see any specific staining. There's just incredibly high background everywhere. However, when we look at a lower antibody dilution and use Tris EDTA as the epitope retrieval mechanism, you can really nicely see clear staining of this CD14. And here's just another example of how the results look in the different buffers. So at Protein Tech, we have our product-specific protocols. And for IHC, we check every antibody in the majority of tissues with both antigen retrieval buffers to see if one works better than the other. So you can see here in our R&D lab, when we were looking at this CD20 monoclonal antibody, sodium citrate did provide some epitope retrieval. However, when we looked at Tris EDTA, you can really clearly here see really nice specific staining that has been uncovered by this Tris EDTA. So make sure that you are aware of the different buffers available and whether or not you need to switch between them if you're not seeing perfect staining. So some tips for antigen retrieval is that it can be best sometimes to heat your antigen solution before applying to the slide. So heating it before we apply to the slide means that you then have more control over the time that you are applying your antigen retrieval for. So say you're heating it whilst it's on the slide, you might then, if you're trying to optimize the timing, you might get some changes because it might heat up differently each time. Whereas if you heat it first, then you can closely optimize changes in your antigen solution incubation time. And if you're using enzymatic retrieval, so Pierre, this can damage tissue morphology. And if not specified by your manufacturer, always optimize first with HERE, Tris EDTA, and see how it goes from there.